I believe this is the PowerPoint I wanted to go over. I'll go over it anyway. So the main thing about this next unit is electrical power. Keep your mask on, Thomas. So, does anyone know what kilowatt hour is? Has anyone ever looked at their electrical bill? Does anyone know what watts are? Like a 60-watt light bulb? So we're going to be looking at electrical power. We're not going to be going over. So power is equal to work over time. Work, if you remember when we go over it, is force times distance. Yeah, you don't really need to know those. All you need to know is power is going to be equal to current times voltage. These are sub-formulas for this. In terms of electricity, work is voltage times charge, and current is charge per time. I don't teach in this class work and current or charges. But electrical power, for the purpose of this class, is just current times voltage, known as Joule's law. So Ohm's law relates current, resistance, and voltage. Joule's law adds in power, and power is just current times voltage. So power is the power consumed by a resistor R, and the units for power is joules per second, commonly just called a watt. So the unit for power is going to be a watt. So what is the power unit? No, I'm telling you, what is the power unit? So resistors are actually sources of thermal energy generators. A resistor generates thermal energy. Not very useful unless it's a space heater. A space heater is basically a big resistor. So we have Joule's law. Power is equal to current times voltage. And so this is Joule's law. And what was Ohm's law? Voltage is equal to current times resistance. Well, we can combine that. This voltage here is the same as this voltage here. So I can plug that in. Power is equal to current times R. That's your voltage. Current times current is current squared times resistance. So power is equal to current squared times the resistance. We can also rearrange this equation. The true Ohm's law is current is equal to voltage over resistance. This is the true form of Ohm's law. So I can take this I and plug it in for this I. So we have power is equal I is just voltage over R times voltage. So this is your I. I'm just plugging it in. So we have a voltage times a voltage. That's voltage squared over resistance. So power is also equal to voltage squared over resistance. So, you could either use Ohm's law and Joule's law separately, or you can combine them and get these other equations. So if you're told current and resistance, you can plug it into this equation and get your power. Again, if your current, I, is in amps, and your voltage, V, is in volts, and your resistance, R, is in ohms, your power, P, will be in watts. And watts is abbreviated with a capital W. And a watt, 1 watt, is equal to 1 joule per second. So you're using 1 joule of energy every second. So a watt, or power, so this is the unit for power, is a measure of how much energy is being used or generated every second, or some unit of time. They like to bill you by the hour for electricity, so they use hours. What is a measure of how much energy is being used or generated every second. So to derive the following, use Joule's law and Ohm's law. And I like to remember Joule's law as PIV. So Ohm's law is Veer, Joule's law is PIV. And I will like to say this, Joule's law technically isn't this equation. Joule's law, let me actually Google a proper definition of Joule's law. It's way more complicated than that equation. So Joule's first law deals with the fact that heat is generated when a current flows through some conductor, such as a resistor. Joule's law is actually relating to the fact that heat is produced whenever you run electricity through it. That is actually Joule's law. Joule's law reflects the fact that heat is generated when electricity flows through a conductor. Which is why I really wouldn't associate this equation with Joule's law. Let me go back real quick and do this. I really wouldn't call this Joule's law. Just remember, power is PIV, Ohm's law is Veer. So let's do a problem. The answer is on the board. Let's see if I can get it right. The current through a car motor is 150 amps. The battery that is used is 12 volts. How much energy is supplied by the battery in 5 seconds? Alright, what is it? Wrong. So close. 9,000 joules. So I will say this, I forgot to mention this. Energy. Energy is equal to power times time. So this is your energy, this is your power, and this is your time. Time needs to be in seconds, power needs to be in watts, and energy will be in joules. Because a watt is technically a joule per second, so if you multiply power, if it's in watts, or joules per second, by seconds, the seconds cancel each other out. So that problem stated that the current is 150 amps, the voltage is 12 volts, and the time is 5 seconds. We know that power is equal to current times voltage, so that's 150 amps times a voltage of 12 volts, which is equal to 1800 watts. And we know that energy is power times time, so 118 watts times 5 seconds is 9,000 joules. So, let me ask you this. What is a kilowatt hour? So, kilowatt hour. What is this a unit of? Kilo is a prefix, meaning 1,000. So, what is this a unit of? Keep y'all's mask on. So what is this unit? This kilo means 1,000 watts. So this is power. And what is an hour? The unit of? So we have power times the time. So what is a kilowatt hour? Energy. You are billed by how much energy you use, not how much power or electricity is used. You are billed on how much energy you use. So if you wanted to figure out what appliance in your house is using the most energy and costing you the most money, which we will do in this class, we will figure out, we will actually work through a lot of common household appliances. Basically what you do is you figure out how much current, how much voltage is being supplied by it, and then we figure out how much is being used. How are you keeping it on 24/7? Well, then you would then be either you can either do it in joules or you can do it in kilowatt hours, and we can figure out how much energy is actually being used. If it's being only used 8 hours a day for a week, you can figure out the weekly cost, and we'll actually look up the price of electricity in Broadus, Texas, and actually get some real values. FYI, or I should say, question: what do you think costs the most money in your house?
Wait, are we talking about things that are like electric?
Keep your mask on.
Yeah, electric or
Yes. Yes.
refrigerator.
It's your AC. Specifically your heater.
What if we don't use it?
Then you'll save money.
If we don't use it,
Keep your mask on and don't eat in the class. This isn't breakfast or lunch. So a kilowatt hour. I guess they leave off the R. I put R on it when I wrote it. And they usually put a dot between the W and the H because the K and the W is attached. But this is a unit of power. So let's do a problem. So a small desktop radio has a resistance of 8,000 ohms and a voltage of 120 volts. So these are the given. Question A, how much current does it draw? Draw in this sense means use. So this is Ohm's law. Ohm's law states that current is equal to voltage of a resistance. Or if you just remembered here, voltage is equal to current times resistance. Current is voltage over R. So your voltage is 120 volts over 8,000 ohms. Which is equal to 0.015 amps. How much power does it use? So power is equal to current times voltage. So 0.015 amps times a voltage of 120 volts. And that gives you 1.8 watts. We could have used the alternative formula. Power is equal to voltage squared over resistance. So 120 volts squared over 8,000 ohms. And that also gives you 1.8 watts. So here's the question, main question. How much money, or how much does it cost to run the radio for 12 hours if 1 kilowatt hour cost 15 cents? Yes. So, we know that 1 kilowatt hour is equal to 15 cents. To get from power to kilowatt, so power is in watts, we divide by 1,000. Hello? Oh, I forgot about it. Alright. So 1.8 watts is equal to 1.8 divided by 1,000 kilowatts. Kilo means 1,000, so 1,000 divided by 1,000 cancels each other out. that's equal to 0.008 kilowatts. Now then, to get kilowatt hours, we just multiply.
If there are any junior high students that need to take a retake photo, please report to them for you. Any junior high students wanting to retake the school photo, please report to them.
Y'all quit talking. So to convert, or to get kilowatt hours, we just multiply the kilowatts to the hours. Note, if this question is in seconds and you're trying to get kilowatt hours, you have to convert watts into kilowatts and seconds into hours. So this is equal to 0.0216 kilowatt hours. So this is how much energy in kilowatt hours we're using. So how much does it cost? If 1 kilowatt hour costs 0.15 cents. We would multiply it. So 0.0216 kilowatt hours. We would multiply, making a little grid, multiply this by the fraction 15 cents per 1 kilowatt hour. So that would be 0.0216 kilowatt hours times the ratio 15 cents to 1 kilowatt hour. Kilowatt hours cancel out and we're just left with money. And we get a total cost of $0.00324. So less than a penny to run a radio for 12 hours. Here's something that might save you a lot of money. Let's go. All right, which space heater do you think is better? This one is $68, and this one is $20. Which one is better? Which one produces more heat? They both generate 1,500 watts of power. That has two settings. It has a low temperature setting and a high temperature. The high temperature setting is 1,500 watts, and this one is 1,500 watts. They both produce the exact same amount of heat. When you're buying a space heater, almost all space heaters you can buy are going to produce the exact same amount of heat. There is some differences, such as oil. It heats oil up first, and it takes oil a long time to heat up, which means if the power goes out, it can actually still be heating up for a few minutes. Or or it can do some low settings. You can get around this, but basically, without tripping the breaker, all space heaters are usually close to the max amount of wattage they can use without tripping the breaker. 1,800 watts is probably something you can find that produces more heat. I think the maximum is 2,100 watts or 2,500 watts. After that, you risk catching your house on fire. Your breaker should trip anytime you plug it up. But if you understand the fact that this power is being used to produce heat, then there's really no difference between any of these space heaters you can find on Amazon. All you need to do is look for wattage. It's still producing the same heat. How would blowing air? It still will distribute on its own. Mm-mm. It might get the other side of the room faster. So instead of looking at 5 minutes to heat the other side of the room, one without a fan would heat the other side of the room in like 10 or 15 minutes. But it's really you walking around would do the same thing as a fan almost, because you can't really feel. Can you feel the fan across the room from a space heater? Then it doesn't really blow hard enough to push that warm air that far. You might get it faster a few feet away from it, but really not too much. There is differences in oil based, because it can heat up the oil and then turn it off, and then it can start heating up at the oil again when it falls so low. So it can heat it up to like 80 degrees, and then it'll let it cool off to 75, and it'll reheat it back up to 80, and that way it could be more efficient. Especially if you're not losing too much heat in your house. If your house is well insulated, an oil heater could be better. Oh no, this is 1,500 watts, so it uses the exact same as this. But if your room isn't losing too much heat because your walls are very well insulated, then this one can turn off and let the hot oil keep it up. But overall, really, it doesn't save you too much. This again. This one right here for a large room. It says it advertised $150. This is designed for a large room. No different than this $20 one. Produces the exact same amount of heat. It's energy. It can't create more energy than it's able to use. So let's do some example problems. Oh, by the way, does a 60 watt light bulb actually use 60 watts? Why not? I mean, yeah, it's going to limit it to whatever wattage it's designed for. And you're kind of right in that if your house isn't designed to be producing full current, you could screw it up and not reproducing. But so back in the day, they designed a 60 watt light bulb. And some idiot, and I will call him an idiot, said this 60 watt light bulb produces some brightness. And it shines light. And thus, it is brighter than a 40 watt light bulb. So, this is where the idiocy comes in. Someone then figured out how to make a 30 light bulb that produces the same brightness as this light bulb. So it uses less energy but is just as bright. Now then, this marketing guy says, hey, mine is 60 watts. 60 watts is higher than 30. Yes, it means it's costing you more money, produces the same brightness, but 60 watts is higher than 30. You should buy 60 watts. So this is where marketing has screwed up. A person would buy a 60 watt light bulb just because it is a larger number than 30 watts, even if this one saves you more money and is brighter even than this one. A lot of people consumers are not very intelligent. There you go, right? When it comes to making decisions. And so in order for this guy to sell his light bulb, what he did was say, this is 60 watt asterisk. And if you read on small print, it says, this is equivalent to the old time 60 watt light bulb in brightness. And then you should see also somewhere actually uses in small print because they don't want to make it large because people don't understand how to use watts. Actually uses 30 watts. So when you buy a 60 watt light bulb, chances are it's going to use something less, and you're buying something that was equivalent to an old 60 watt light bulb in the past. But let's pretend for a second that we had a 60 watt light bulb that actually uses 60 watts. And let's look up online electricity cost Broadest Texas kilowatt hours. I think it's 11.74 cents. So 1 kilowatt hour is equal to 0.1174 cents. How much would it cost you to leave this one light bulb on for a full year? Well, how many days are in a year? 365. We're not including a leap year. So let's do 1 year, and we're going to multiply it by 365 days per 1 year. Years cancel out. How many hours are in a day? So 24 hours in 1 day. So a day and days cancel out. So 1 year is equal to 365 times 24 days times hours. So that's 8,760 hours. And 60 watts is equal to how many kilowatts? So 60 watts times, there is 1 kilowatt in 1,000 watts. So we divide the watts, that cancels out doing this kilowatts. So 60 divided by 1,000 kilowatts, which is 0.06 kilowatts. So there's our kilowatts, that's our hours. Define the total energy. Energy is going to be equal to your power times your time. So our power is 0.06 kilowatts. Our hours is 8,760 hours. So you use a total of 525.6 kilowatt hours. So that's the total amount of power. And to get your cost, we're going to multiply. So we know that for Texas, or East Texas, we want to put it's 11.74 cents for 1 kilowatt hour. So kilowatts cancel out. Which is equal to $61.71. Rounded to the nearest penny. So leaving a 60 watt light bulb, assuming it truly uses 60 watts, gives you would cost $61.71. Now, and Michael, put your mask on. How many light bulbs do you think you have in your house?
Hold on, you have exactly 1, 2, 3, 4, 5, 6, 7.
Yeah. All light bulbs, yes.
Oh wait, no, we have one.
Keep your mask on.
We have 13, 17.
Keep your mask on, John. And lift your head up. So let's use 15. I'm taking the average. So 15 light bulbs left on all year would cost you $925.65 a year for 15. Now let's look up the actual values So that's what I'm about to look up. So 60 watt light bulbs. Note, you'll see this word here, 60 watt equivalent. They do not actually use 60 watts. So let's look at the cheapest ones I can find. They'll be the least efficient. Oh, these are LEDs. I'm looking for incandescent ones. LEDs are very efficient. They only use... So this 60 watt equivalent light bulb is LED and only uses 8.5 watts. So LEDs, again, this 60 watt equivalent means this is the brightness. So the old-timey 60 watt lights that actually use 60 watt lights produce some brightness of light. You can, with LEDs, achieve the same brightness with using only 8.5 watts. Let's see if I can get incandescent. I have no clue how to spell incandescent. Just in. Can't find any non-LEDs because you should really be buying LEDs. They save you so much more money. No, they can produce the same light. Like these produce the same. Yeah. Y'all all sit that down. Where y'all go? Okay. Okay.